Dinosaurs, the magnificent creatures that once roamed the earth, continue to fascinate us. These ancient beings, with their immense size and diverse forms, have captured the imagination of scientists and enthusiasts alike for generations. From the towering Brachiosaurus to the fearsome Tyrannosaurus rex, each species offers a glimpse into a world long gone. We marvel at their size, their power, and their reign that lasted millions of years. Their bones, now fossilized, tell stories of a time when these giants dominated the land. But beyond their physical presence, there lies a deeper question that intrigues many. How long did these incredible animals actually live? But have you ever wondered about their lifespans? Did they live as long as modern-day reptiles, or did their massive bodies require shorter life cycles? The answers are not straightforward, and the quest to uncover them is filled with scientific intrigue. How long did these incredible animals actually live? Some estimates suggest that large dinosaurs could live up to 70 or even 100 years, while smaller species might have had much shorter lifespans. The clues lie in their bones, which, like tree rings, can reveal age and growth patterns. Did they age quickly or slowly? The rate at which dinosaurs grew and aged is a topic of ongoing research. Some studies indicate rapid growth spurts during their juvenile years, followed by slower growth as they reached adulthood. This pattern is similar to that of modern birds and mammals. Join us as we delve into the mystery of dinosaur lifespans. The study of dinosaur life cycles is complex and ever-evolving. Each new fossil discovery adds a piece to the puzzle, helping scientists to refine their understanding of these ancient creatures. The study of dinosaur life cycles is complex and ever-evolving. By examining the microscopic structure of bones, scientists can determine growth rates and age at death. This process, known as histology, has revolutionized our understanding of dinosaur biology. Paleontologists use a variety of methods to piece together the puzzle of dinosaur growth and longevity. By examining fossils, analyzing bone structures, and comparing dinosaurs to their modern relatives, we're gaining a clearer picture of their lifespans. Techniques such as radiometric dating and isotopic analysis also play crucial roles in this research, and comparing dinosaurs to their modern relatives, such as birds and reptiles, scientists can draw parallels and make educated guesses about how these ancient animals lived and aged. Birds, being the closest living relatives of dinosaurs, offer particularly valuable insights. We're gaining a clearer picture of their lifespans. As we continue to uncover more fossils and develop new technologies, our understanding of dinosaur lifespans will only deepen, revealing more about the lives of these fascinating creatures that once ruled the earth. Dinosaurs, like modern animals, exhibited a wide range of growth rates. Smaller dinosaurs, some no bigger than a chicken, grew up quickly. These agile creatures, like the speedy Velociraptor, reached adulthood in just a few years. Their smaller size meant they needed less time to reach their full size. In contrast, the giants of the dinosaur world, such as the long-necked Brachiosaurus and the mighty Tyrannosaurus rex, had a much longer journey to adulthood. These behemoths could take decades to reach their full size. Imagine a Tyrannosaurus rex adding pounds of weight every day during its teenage growth spurt. One fascinating way scientists can estimate dinosaur age is by examining growth rings in their bones. Much like the rings inside a tree trunk, these rings, visible under a microscope, can reveal a dinosaur's growth history. Wider rings indicate periods of rapid growth, while narrower rings suggest slower growth phases. By counting these rings and analyzing their spacing, paleontologists can estimate not only a dinosaur's age but also its growth rate at different stages of life. This technique has revolutionized our understanding of dinosaur lifespans, providing valuable insights into their life histories. The life of a dinosaur began with an egg. Some dinosaurs laid small bird-like eggs, while others produced enormous eggs, some even larger than a rugby ball. The incubation period for dinosaur eggs varied depending on the species. Some eggs hatched relatively quickly, while others required months of incubation. Once hatched, baby dinosaurs faced a world full of challenges. They had to find food, avoid predators, and navigate their environment. The first few years of a dinosaur's life were critical for its survival. Section 5. Growing Up Dino, a Race Against Time. For many dinosaurs, growing up was, well, a race against time. From the moment they hatched, these ancient creatures faced a world filled with dangers and challenges. Predators lurked around every corner, and the environment itself could be unforgiving. The young dinosaurs had to grow quickly to survive. They needed to reach a certain size to deter predators or to compete for mates. This wasn't just about survival, it was about thriving in a world where only the fittest could make it. The larger they grew, the better their chances of fending off attacks and securing their place in the ecosystem. This pressure to grow quickly is reflected in their growth rates. Paleontologists have discovered that many dinosaurs experienced rapid growth spurts during their juvenile years. By examining the growth rings in fossilized bones, scientists can determine how fast these creatures grew and how old they were when they reached maturity. Some dinosaurs, such as the duck-billed hadrosaurs, could reach an impressive size within a decade. These herbivorous giants had to grow quickly to avoid becoming prey and to compete for resources. Their rapid growth was a testament to their resilience and adaptability. This rapid growth required an enormous amount of food and resources. Young dinosaurs had to constantly forage and hunt to meet their nutritional needs. The competition for food was fierce, and only the most resourceful and determined individuals could secure enough sustenance to fuel their growth. Dinosaurs had to consume vast quantities of vegetation or meat to fuel their growth spurts. Herbivorous dinosaurs would spend most of their day grazing on plants, while carnivorous dinosaurs had to hunt and scavenge for meat. This relentless quest for food shaped their daily routines and interactions with other species. This constant need for sustenance shaped their behavior and their interactions with their environment. Dinosaurs developed complex social structures and behaviors to maximize their chances of survival. Whether it was forming herds for protection or establishing territories to secure food sources, these ancient creatures were always adapting to the ever-changing world around them. Section 6. A lush, oxygen-rich world. The world in which dinosaurs lived was much different than our own. The atmosphere was richer in oxygen, and the climate was warmer and more humid. These conditions played a crucial role in the evolution and success of dinosaurs. The abundance of plant life provided ample food for herbivorous dinosaurs, while the warm temperatures supported their growth. Some scientists believe that the higher oxygen levels may have also contributed to the gigantism seen in some dinosaur species. Section 7. The need for speed. Outgrowing danger. In a world teeming with predators, many dinosaurs evolved strategies to improve their chances of survival. One such strategy was rapid growth. By growing quickly, dinosaurs could outgrow potential predators or develop defensive features sooner. For example, the armored dinosaurs, like Stegosaurus, developed bony plates and spikes as they grew, providing them with protection from attack. This need for defense fueled their rapid growth and shaped their evolutionary trajectory. Section 8. How long did dinosaurs really live? Estimating the lifespan of dinosaurs is a challenging task, but scientists have made significant progress in recent years. By studying fossilized bones, scientists can determine growth patterns and estimate the age of these ancient creatures. This process, known as skeletochronology, involves counting growth rings in the bones, similar to how we count tree rings to determine a tree's age. Based on current research, it's believed that smaller dinosaurs, like the dog-sized Compsognathus, may have lived for a decade or less. These small, agile predators had fast metabolisms and rapid growth rates, which likely contributed to their shorter lifespans. Their quick life cycles allowed them to reproduce rapidly, ensuring the survival of their species in a world full of larger predators. Larger dinosaurs, like the mighty Tyrannosaurus rex, likely had lifespans of several decades, perhaps reaching 30 to 40 years of age. The T-Rex, with its massive size and powerful build, grew more slowly and lived longer than its smaller counterparts. Fossil evidence suggests that these apex predators reached their full size in about 20 years and continued to live for another decade or two. However, some giants like the massive sauropods may have lived even longer. These colossal herbivores, with their long necks and tails, were among the largest animals to ever walk the earth. Their sheer size and slow growth rates suggest that they had much longer lifespans compared to other dinosaurs. These long-necked herbivores, some weighing over 100 tons, might have roamed the earth for a century or more. Their enormous bodies required vast amounts of food, and their slow metabolisms meant they grew and aged at a much slower pace. This extended growth period likely contributed to their impressive lifespans. Their immense size and slow metabolism may have contributed to their extended lifespans. Additionally, their large size would have deterred many predators, allowing them to live relatively peaceful lives once they reached adulthood. This combination of factors made the sauropods some of the longest living dinosaurs in history. Section 9. Echoes of the Past: Dinosaurs, Birds and Mammals. By studying dinosaurs, we gain a deeper understanding not only of their lives, but also of the evolution of life on Earth. Dinosaurs share many similarities with birds, their closest living relatives. Both groups exhibit rapid growth rates and lay eggs. Similarly, the lifespans of some dinosaurs, like the sauropods, were comparable to those of large mammals, such as elephants. These comparisons highlight the diversity of life throughout Earth's history and the remarkable adaptations that have allowed creatures of all sizes and shapes to thrive.